Okay, so in this video we're going to go over some aspects of chapter 12, which is performing iterative processing loops, basically, in SAS. How to do loops in SAS. Okay, so the first program that I'm gonna go over is basically program 12.1, named Creating a Table of Celsius and Fahrenheit Temperatures. This is a basic example of a do loop in SAS. So I'm creating a data set called convert temperatures. My goal is to create a table that has temperatures in Celsius from 0 to 100 Celsius degrees and the corresponding Fahrenheit temperatures. So this part here, the do statement, basically is telling SAS, okay, create a variable which is called temperature C, which is just a series of numbers from 0 to 100 by 1, increasing by 1. So this variable will be a vector of numbers 0, 1, 2, 3, 4, 5, all the way to 100. And then create a variable called tempf, which is basically a function of the temperature in Celsius, 1.8 times the temperature in Celsius plus 32, which is the formula that you use to convert from Celsius to Fahrenheit. So every single time that you do this, so every single time that a temperature in Celsius is generated, 0, 1, 2, 3, and the temperature in Fahrenheit is computed, we will output that, and it will be stored in the convert temperature data set. Then end, that ends the loop, or the iterations, and then run. And then we have a proc print procedure that will print the data convert temp, and we'll see how it looks. So let's run it. Let's check that everything went fine, no errors. So there you go. So basically we created a data set that, has a temp C variable, which is a vector of numbers from 0 through 100 that goes up by 1, 0, 1, 2, 3. So in every iteration, SAS is adding 1 to this, to temp C, 1 and 1 more. And then it computes the corresponding temperature in Fahrenheit degrees. Okay. Now, so that's a simple example of a do loop. Another application of the do loop is to graph equations. Okay, and this program that I'm going to show you is pretty similar to program 12.2, although it's not the same function. I call my data set quadratic, as in a quadratic equation, right? Now, I'm telling SAS, do from x equals to -6 to +6 by 0.01. That means that in every single step of this loop, SAS will add 0.01 to the previous number. So I'm gonna basically have a vector of numbers that goes from -6 to +6, jumping from one to the next by 0.01, right? So be -6 and then -6 plus 0.01, which is -5.99, and so on and so forth, up to 6, +6. And in every step, we compute the x, and then we compute the value of y that corresponds to that x. In this case, it's a quadratic equation, 3 times x squared. This is the way of writing squared, or raised to any power, with 2 asterisks, minus x plus 5. That's a quadratic equation. And then on every single step of this do loop, we output x and y, which goes into this data set quadratic, then end when we reach the end, and then run. Now, I also have a proc sgplot, which is what I use to plot plot variables in SAS, right? To do plots. So at proc sgplot data quadratic, because I'm plotting this data set, series. Well, this is going to tell SAS what is the x and what is the y that I want to plot. Well, the x is just the x. I could have called this whatever. Maybe, independent variable, independent variable. But here x means whatever is on the x-axis, y is whatever is on the y-axis. So I'm basically saying SAS, do a plot, this versus this will be on the x-axis, this will be on the y-axis, and then run. So let's see how this looks like now. Well, you see, this is the plot of the parabola that corresponds to this equation here. Now, if we want to see how the quadratic data set looks like, we could go here to output data. You see the value of x, we started with -6 and we go up to +6. Well, I mean, it's gonna take forever because we have 12,000 rows, so that's why I didn't print that. But anyways, you know, it goes up to +6. And it computes the corresponding value of y for each of the values of x. And so as you can see, it goes up by 0.01 every single step of the loop. So, and then we have the graph of this equation here. Okay. Now, the third program that I want to show you is related to the do-while statement. Do-while statement. This is very useful when you're doing iterations or loops in SAS. So I have called my data set geometric growth. This is going to be basically a geometric series or a geometric sequence. We're going to start with the value of 3. So I call this value 3. This is one of my variables. The rate is 1.2. So in a geometric series or sequence, each of the new values is the previous one multiplied by the rate. So the initial value is 3, then the first value that comes after that is 3 times 1.2, then the next one is whatever you got there multiplied by 1.2. So you always keep on multiplying by 1.2 every single time to get the new term in the sequence. This is something that you probably saw in your algebra class. So the do-while statement tells SAS, okay, you're going to do this loop, these iterations, while this condition is true. Okay, so you're going to keep on doing iterations while the value is less than or equal to 415. Okay, so this iter plus 1, this is initializing my iteration variable in 0, and then this tells SAS that in every single step I'm going to increase the value of my iteration counter by 1. Now every single time that I run this loop, or that the loop runs, the value, the variable value, will get multiplied by 1.2. So it will be the old value multiplied by 1.2. And then output that into the data set. And then while this condition is true, the loop will continue. And then once this condition is not true, it will end. Now I have written here drop rate because I don't want in my output to have the rate as a variable, because it's just 1.2 every single time. So let me print this, let me run this part before doing the plot so you can see how it looks like. Right, so the initial value is 3. So every single time, with every single iteration, see iteration 1, iteration 2, iteration 3, iteration 4, 5, we get a new value, which is the previous one multiplied by 1.2. So this is actually 3 times 1.2. Now 4.32 is 3.6 times 1.2. This is the previous one multiplied by 1.2. So the program kept running, the loop kept running until we hit this condition, right? Value is less than or equal to 415. Well, you see, this value here is 412, okay? So that is the last value that is less than or equal to 415. So it stops right after the condition was fulfilled. Okay, so that's how it looks. That's how it's going to be with the do while statement, right? Now, if I run the whole thing, it will also give me a graph of the value in the y-axis and the iteration in the x-axis. As you can see, it's kind of like an exponential growth, right? So it iterates just right after the condition is fulfilled. Okay. Now, program 4 kind of like resembles or is dealing with the same thing as program 12.6, which is the do until statement. This is another way of achieving the same thing. While, when you do while, it will, the loop will run until, while this condition is true. And it will stop right after it. With the do until, basically, this will check this condition, and once this is fulfilled, it will stop, right? So we will be doing the loop until the value is greater than 8,000. So after that, we stop, right? So I have called this data set interest. We start with an initial value of 1,000. So let's say that you have $1,000. You put $1,000 in a savings account that gives you a 7% rate of interest. So you want to see how many years it will take you to reach $8,000. And this is compound interest. Let's assume that you're not putting in any more money into there. It's just, it's just growing by the interest. So my iteration variable here, I'm going to call it year. So year starts at 0, and then year 1, year 2, year 3, year 4, year 5, year 6. And then for every iteration, you're going to take the value, whatever the value was. Let's say, for example, it was initially 1,000. And you're going to multiply by 1 plus the rate. So this is, 1.07, because that's a 7% increase. And then for the second, and then you're going to output that value, right? And also the year. And then for the next year, now you take the new value and then you multiply by 1.07 again, and so on and so forth, right? And every single time you're outputting those values. I said drop the rate because the rate is just going to be constant 0.07. I don't want that to show on my table. So if I run this and I print it, you'll see what I'm talking about. So for the first year, I have $1,070. And then for the second year, I'll have this multiplied by 1.07, which is this. And it will keep on doing it until we hit more than 8,000, right? So here. So in year 30, we have 7,612. In year 31, we are already over 8,000. So it stops there. So we know that it will take us 31 years to hit this mark, which is that the value is higher than 8,000. Now we can also plot this and get this curve that tells you, according to the year, what would be the money that you will have in your account. Okay. Now program 5 is dealing with the same thing as program 12.10, which is the continue statement. In this case, for example, let's just spin on this program, right? Let's say that you don't want to see all the values for all the years. You just want to see the values after your account hits more than $6,500. So you're doing the loop, the same program, but then before you output the values, you're gonna tell SAS if the value is less than 6,500, then continue. So go back here, continue doing the loop, and don't output the values into the data set. So just keep on doing this. When the value is less than 6,500, then output them, right? So if we do that, you'll see that now I only have the values that are more than 6,500. So year 28, 29, 30, and 31. Okay? So those are some examples of what you can do with loops, or as it's called, iterative processing in SAS. There's more things that you can do. You can create many different programs making use of do loops, but these are just some examples.